Hi, we're Team 11, and we're going to talk about the geometric para-aware multimodal learning. So these are the members and our roles. Our team consists of Dongwan Chi, Jongbin Cho, and Hyun Ryu, and Jin Myung Choi. So first, the background. So while neural networks excel at semantic information, such as image classification or object segmentation, inferring geometry in 3D has been extremely hard to learn. And that's the reason why we rely on classic 3D computer vision techniques such as stereo vision and structure from motion. However, recently, due to the large amount of 3D multi-view data, we are able to learn 3D in a data-driven way. And these models are called geometric foundation models. The most representative work is the VGGT, which inputs multi-view image or one image and outputs the estimated cameras and the depth maps and the point maps and the point feature tracks. So these are our hypotheses. So geometric foundation models will have stronger 3D information in its latents so that we will be able to utilize these strong 3D information. And secondly, because geometric and semantic features have different characteristics, we thought that they will have a trade-off. And also, we thought using this strong 3D information inside the VGT's latents will boost multimodal LLMs in spatial reasoning abilities. So the first experiment was about exploring the latent space of geometric foundation models. So we analyzed VGT features on two tasks. First, whether they have semantic information or whether they have geometric information. So the setup is the following. We extract dense latents from VGT for each image or scene and repeat it for each layer of VGT, and then evaluate it on geometric and semantic tasks. So for the semantic task, we use Teeny ImageNet, and we trained by linear probing with the features and evaluated them on classification accuracy. So it turns out that in the first few layers of the VGT, which is basically very similar to the Dino layers, the accuracy was very high. But at the later layers of the VGT, the high-level semantic disappeared, shown by the decreased accuracy in our linear probing evaluation. And for the geometric task, we use multi-view images and qualitatively saw results on feature point matching. These are the results. So given a query image with a query point depicted in red, we're trying to find out what point has the most similar feature from the query point given another view of the scene. So the blue dots are the points where the features are most similar to the red dot. And as you can see, we queried on the right hand of the airplane, and in the early layers of the VGT, the most similar part was on the left side of the plane, showing less geometric information. However, in the later parts, you can see that the blue dot moves to the right side of the plane, which shows that the later parts of the VGT has much more geometric information. So the experiment one results are that geometric foundation models have better 3D information than visual foundation models, but they have a geometric semantic information trade-off. And for the second experiment, we tried using these geometric foundation models, latents for MLMs for 3D reasoning capabilities. So we trained in the lava setting and evaluated its capabilities on general visual question answering and geometric question answering. So for general visual question answering, we used VQA-V2, but we didn't get the results yet. However, we currently have results on the ERQA dataset, which consists of spatial visual question answering. So the model architecture is as follows. We're using the standard lava architecture. And for lava, you need two steps to pre-train. You need you need to pre-train the projection layer and then do an instruction tuning, fine-tuning. But that requires days of 800 NVIDIA GPUs, so we just train the projection layer and the lower layers for less compute. So the baseline model is using CLIP with an LLM, and our model is using VGT with an LLM. The results are the following. Using CLIP as a feature extractor only achieved 32% accuracy, while using VGT achieved 77% accuracy, which shows that VGT actually has much more geometric information, and that helps downstream tasks such as training multimodal LLMs for spatial reasoning tasks much more effectively. So in conclusion, VGT features has better geometric information than visual foundation models, and these features help multimodal LLMs with geometric reasoning. However, these features lack semantic information. So in the future, researchers should develop a method that has both semantic information and geometric information. Thank you for listening.